Unit 7, our last unit was our statistics unit, and the first question asks, are these dependent or independent events? So it says we have a bunch of paper clips in the drawer, we pull one out, and then we put it back in the drawer. If I pull a paper clip out again, does it depend on what happened the first time? So imagine I pull a red paper clip out, and then I put it back in. Does that change the probability that I draw a red paper clip the second time? And the answer is no. It doesn't change the probability, so these are independent events. It doesn't matter if I draw a red paperclip, a green paperclip, or a blue paperclip the first time. If I put it back in the drawer, it's the same odds the second time, so these are independent events. Second question says find the mean, median, mode, range, and standard deviation. So the first thing you should do is, on your calculator, go to Stat, Edit, and let's type in all this data. Now I'm typing it in L2, so 9, 9, 10, 10, 11, and I went all the way down for a total of, how many is that? 3, 6, 9, 12, 13 of them. Then, once I typed them all in, I can go to Stat, Calculate, and I want one variable stats. And since I typed mine in L2, I have to add a little bit here and say L2. And I want the one variable stats. This should give you everything you need now. The first thing it says, what's the mean? The mean would be 14.58. So we use X bar, 14.58. The median is, if you scroll down, in here as well, 13. The mode, which one happens the most, so if they're in order, that's usually easy to spot. Looks like there's 2 9s, 2 10s, there are 3 15s, so the mode is 15. What's the range? So the range, if they're in order, is also easy. 40 minus 9 is 31. And then the last one, the standard deviation, in your calculator, it'll do that for you. Standard deviation is SX, which is 8.03. So that's it for our mean, median, mode, range, and standard deviation. And then it says which measure of central tendency is most appropriate for the data. So here you can see that the mean and the median are not quite the same, which means this data might be skewed a little bit. And if the mean is bigger, then usually what that means is the mean's over here and the median is somewhere in here, which means it could be skewed right. We could graph it, and so I can use my calculator to maybe do that. Let's see if I can set this up real quick. I want to graph L2, so I'll change this to be L2, and I'm going to do a histogram, so I can see it's a histogram, and I'm doing L2, well, maybe L2. Now if I go to zoom, and I do zoom stat, I should be able to see, whoa, this ain't good. Alright, zoom stat, I should be able to see the graph, and you can tell that there's a lot of values here when I'm tracing this. There's a lot of values in this 11 to 15 range, but then there's a couple that are way bigger, and that's the 40. The 40 is really the big one. Since the data is skewed, the most appropriate measure of central tendency would be the median, and it's because it's skewed. And remember, when it's skewed, it's the tail, so this is skewed to the right. Let's do the last question, which I think is the same kind of thing. Maybe. Come on. Come on, there we go. All right. This, when it's in the middle, this is sometimes called a bell curve. This is a normal distribution. This thing is struggling. Okay. So this is a normal distribution. This is what we just talked about when it's most of the data is over here, but there's a couple outside to the right. This means the mean would be to the right of the median, so this is skewed right. Here there are 2 modes. This would be a mode and that's a mode, so this is called a bimodal distribution. Then the last one is sort of the opposite of this. When most of the data is off to the right, the mean would be less than the median. This would be the mean and this would be the median. When that happens, this is called a skewed left distribution. So that's it for our stats review, and that's it for our crash course. So good luck on the final.